Welcome to another video. This is for ring final circuit testing. So please like and share, that would be great. Let's get some viewing figures up. So what is a ring final in case you've never heard of one? Well, a ring final, to state the obvious, is a circuit that starts and finishes at the circuit protection, as you can see here. So you can have a number of sockets on a particular circuit, and that is unlimited up to 100 meters squared, and that is providing you do not know what the load is. And the minimum size of cable expected for these is a 2.5, and therefore the protected device can be a 30 or a 32. Ring final circuits themselves, you should be wary of the amount of loading that you put on the circuit. You should not overload it. You should try and distribute the load evenly around a ring final. As the regulation says, you should try and distribute and stop overloads from occurring. It doesn't say remove overloads because that may well happen, but you should try and minimize it, and that means space them out around. So because this is a different type of circuit, as opposed to it's not a radial, the conductor sizes are smaller for the protected device. Therefore, it has its own type of testing, and that is the purpose of this video. So what do we need to do? Well, this installation, every installation should be, before being put into service, should be inspected and tested so far as reasonably practicable. What does that basically mean? It means you should test it before you turn it on and make sure that it is in a fit working condition before energizing. So therefore do your dead tests. So which dead test do we actually do? Well, like I say, this has its own particular test, and it comes under continuity of ring final circuit. There are 3 steps to be covered in this video. Let's get down to it then. So we are going to test circuit number 2 on this distribution board. As you can see, it is a 32 amp type B circuit breaker. So first things we do, get permission. Let's turn the board off before removing the front cover. I'm just going to turn everything off, and we're basically, because it's a dead test, we need to lock it in the off position. So always to remove, before removing the cover, turn everything off. So I've already checked my testers on approving unit, so we're going to go, see, this side is going to be live because it's the incoming supply, so we can definitely prove our supply on here. So this is coming up as 230 volts, but we want to go on the output side to make sure that is dead. So we go line neutral, line earth, neutral earth, and then going to check on my proving unit again. If everything turns up to be 0 volts, apart from obviously on the proving unit, then we now know that this is safely isolated. But remember, incoming supply up here, that is still on. Set to continuity, and we just want to prove the instrument, so we connect into the 2 L1 PE, and we want to prove leads apart, leads together, and as you can see, I've already zeroed up. I'm just going to re-zero them again, so we know that our leads are zeroed. We're now ready to go. So we now know what an open circuit looks like, and we know what a closed circuit check your 0. Step 1 then, little r1, little rn and little r2 is basically we're going to make sure that these are a complete ring. So end to end on each one. And then we go to Rn. Now these are obviously the same size conductors, so these are all 2.5s. Now you'd expect these two to be the same, and actually these are in 2/5s as well, so the CPCs are also in 2/5s. And because it's not steel conduit and trunking, and basically there aren't many parallel return earth paths back, all of these values should be substantially the same. And according to the on-site guide, apparently 0.05, and called guidance note 3, 0.05 of an ohm between each other. So on our test sheet, it would have been circuit way number 2, it would have been ring final. And then the BSEN number, obviously, of the protective device, the type of the protective device, type 2, 32 amp, that's what it was. The breaking capacity, did it have an RCD or RCBO? In this case, it didn't. What is the maximum ZS? Well, the maximum ZS is for the protective device. The reference method relates to how the installation is installed. So look at Appendix 4 in your BS 7671 to give you that information. Size of the live conductors, so 2.5, and this is where little r1 went in, so 1.05, they don't give you a lot of room, 1.05, and I don't need to put ohms in because it already says it up there, 1.05. So here's our ring circuit that would go round the installation. Obviously these come back and into the distribution board, into the fuse, obviously neutral bar, and to the earths. And our associated sockets would be planted around the circuit. So when we do step 1, which is little r1, little r2 and little rn, and these are recorded on the test sheets. What we're doing is we're measuring, so our meter is we put one lead on there, and we measure the continuity, and it will give you a reading around that circuit. And providing there's no breaks in that circuit, you will get continuity. So what this does show is, you've got a continuous ring. It doesn't say whether the ring's any good or not, but it just gives you an idea of what the resistance is. But it will, once you test them all, it will give you an idea whether the connections are tight and the ring is consistent. So we got a reading, and I believe it was 1.05. So that was the resistance of that particular one. What you then do, still on step, is we measure each one in turn, and because they're all made of the same size conductor in this case, then hopefully they should be substantially the same. In fact, they should be plus or minus 0.05 of an ohm if they are consistent in that sense. And then you move on down to the RN, and we got another reading, 1.05 ohms. Now this will only work, they'll only be the same if the conductors are the same, which ours were. Remember, in a twin and earth installation, the R2 will be a smaller conductor size, so it would actually be 1.67 times higher, providing there's no other parallel paths. Now all this goes out the window in a commercial installation, especially when there's steel conduit, steel trunking, and everything's bonded and connected together, because the earth will basically, you might run an extra CPC round it in a ring. However, when you earth the backs of the boxes, and inadvertently they will be earthed anyway, when you do R1 you'll get a reading as we are now, RN you'll get a reading as we are now, or you should do. However, when you do the R2 reading end to end, when you're doing steel conduit, steel trunking, or steel installation in general, this reading, chances are, will come back really, really low. So don't worry, it doesn't mean you haven't got a circuit, it just means what you've got a really good earth path, because the current is just going out to the mass of earth, the conduit, and then coming straight back again on whichever connections you have. So don't worry too much if that's what you end up with, but on the whole, our particular installation, we have this. Step 2 is to turn them into figure of 8, and actually this is the one that's not recorded on the test sheet, but could be recorded in remarks. So we want to connect opposite ends for R1 and RN. Now these haven't been marked up, So I don't know which one they are, which way round they are, because it's wired in singles, very difficult to tell. So I'm going to have a 50-50 chance of getting it right, and hopefully I will get it right. If not, it will demonstrate one way or the other. So connect those two together, opposites to opposites, that's what we want, but it doesn't matter because these are not marked. If it was twin and earth, it wouldn't be a problem. You'd know which leg of the ring goes which direction if you had to swap opposite ends. But it doesn't matter, we'll soon find out. So we're now going to swap leads because obviously we're doing sockets, so it's easier, and you should be going from the front of the socket and not the back of the socket. The reason being, if you go to the back of the socket, basically what you're going to do is you're going to put your probes. You're going to create more work because you've got to take all the socket fronts off, but you're going to put your probes where the line and neutrals are, and not necessarily where they should be connected. So if we use the socket, we can't really go wrong because obviously this is always going to be connected correctly. What you must make sure you do, though, because it's the line and neutral we're measuring, it's these two that go in the L and the PE. So that also goes where the red one went before, but this one goes where the green one was in the actual meter itself. Okay, so that one is right by the distribution board. The fact that it's come out at 0, 0, because it's such a short run, it tells me actually I've got my connections around the wrong way. So what we should notice, if I move on to the next socket, which is a little bit further away, hopefully what you'll see is the readings will go up. And as I continue around the installation, the further away down the ring you go, the higher the reading will be. It does depend how far around. And then eventually, whichever socket you then go to, depending on how it's been wired, you should read the reading will probably start to go back down again as you start to get closer to the beginning of the circuit. So the fact that the readings were starting to go up as we get further away from the ring and then coming back down again as we start to go round tells us these are round the wrong way, so we need to swap them. So now we're going to go around again to every single socket, testing between line and neutral in the figure of 8. Step 2, what we're looking to do is do the figure of 8, so R1 and Rn. So what we're looking to do is connect opposites to opposites. So we make a figure of 8 ultimately. So this is why I'm marking up the legs of the ring and twin and earths, obviously you can see anyway. So we want to connect this one over to that leg of the ring and this one over to that leg of the ring. And why would you do that? Well, it's about getting the maximum ohmic value of this entire circuit and put it into a figure of 8. That's exactly what you will get. So now when you go around and you go now test at every point, what you're doing is if we measure from, let's say, here and here, current from one lead, so you've got your meter, so there's a socket in this location, and that's where we're now testing from, and you do this from every socket, remember. Current now will go back through this way, round and to that lead. It will also go back that way through the meter. So it has 4 different directions is where it ultimately goes, because there's ultimately 4 connections either direction on each one. So this is what you tend to do. And now because we connect like this, we get the total ohmic value of all the circuits. Whereas on the previous, when I did it a second ago, I got it around the wrong way, which was rather fortuitous. Because what I actually had was this, and what you found was, because the first socket was here, it still goes 4 directions, but current will always take the easiest path. So actually this is quite a low ohmic value, this direction, so hence it gave you a low reading. And as you then go round the circuit, you're getting further away until you get to there. In my theoretical one, that's the midpoint because it's equal distance either way, so that's your maximum value. If you could get the equal distance, that would be your R1, R2. But by doing the figure of 8 connection, we always get the equal distance, the midpoint of the ring, no matter where you go. So what that does is it proves that your circuit is a true ring. So we got R1 plus Rn, we got 0.51 ohms. Now what the idea is, we can now check this, we can verify. Although this one isn't recorded on the test sheet, if you ever go to any test and inspection exam, they would be expecting you to do this, obviously, and obviously you're supposed to anyway, but they'd expect you to verify whether this is correct. So what we can now use, we can use these figures here to confirm whether this is correct. So the formula for that is R1 plus Rn is equal to little r1 plus little rn divided by 4. And the reason it's divided by 4 is because what we just spoke about a minute ago is going 4 directions. So now if we put these figures in, 1.05 plus 1.05, add those together and then divide that by 4, what you get is 0.5025 ohms. Now that's got 4 decimal places now, so 0.5 or 51 is basically what you're getting, and that's what we got as we went round. So that proves that the sockets are actually on this ring because it tallies up with this. But it also proves, and this is why we do this, it proves the line and neutral are in the bottom 2 pins of each socket. It doesn't say whether they're around the right way, it just tells you the bottom 2 pins, because that's where we were connecting from, are on the line and neutral. Okay, so that's those done. What we now want to do is, well, we don't need the neutrals out anymore, so they can go away. I'm a great believer when testing is not to disconnect as much as you can, to be quite honest. So now we need to do the same again in a figure of 8. What's the chances? They're not marked, but I will mark them for next time. There's nothing wrong with you if you wanted to put these in connector blocks, however you wish to do it. I find crocodile clips work just as well for me. So now we've done the figure of 8 again, so this is step 3, so this is now your R1 and R2 because the last one was R1 and Rn. And again we should be going around the ring circuit, and you should be getting substantially the same reading as you go round if you've got them round the right way. If they're round the wrong way, again they're going to start off low if you're near the distribution board, and the further away you go, the higher the reading, until you start coming back again, so the readings will constantly change as you go around the ring circuit. So we're looking for something that is going to stay the same. Remember, when carrying out R1, R2, it's this pin and the other pin that you're going to do. So actually we need to swap them in from R1, Rn. We put those 2 in, we're doing R1 and R2. Please make sure you put these 2 in your meter so you're testing on the correct one when we insert it in. Okay, so we've gone round and we note the highest one, they were all substantially the same, within 0.05 of each other, and it's the highest one, R1, R2, that goes on your test sheet. Step 3 then was connections at the incoming point again. So this time, opposite ends to opposite ends, link them out again. And now we go around and test at R1 and R2. So remember, you've swapped the plugs over in your leads. And therefore, we go around every socket. And again, and we're testing between those 2 conductors there. And this then is the R1 and R2. And providing they're all on the ring, they will all be substantially the same. So what we've now got is R1 plus R2 equals, and we got 0.51 ohms. And again, this can be checked. So R1 plus R2 is equal to little r1 plus little r2, add them up and divide by 4. Remember dividing by 4 because it goes 4 directions on each lead. And then we put those figures in, so they were 1.05 plus 1.05 divide by 4, and we should get 0.5025 ohms. And it should be within 0.05 as we go around, and that's exactly what we did get. So those are the readings. Now, what this now proves is that the polarity, and this is why we do every single socket outlet, because you've now not only have you proved continuity and you've recorded the R1, R2, and you've found the highest ohmic value of the circuit, you've also now confirmed the polarity of every single socket. So we now know on every single socket that the top pin is the earth and the bottom left is the neutral as you look at it, and then the bottom right is the line conductor. Because if they'd have been round the wrong way, as we'd have gone round, you would have got an open circuit to tell you that the line and neutral are reverse polarity. So by doing it this way, you confirm you have a ring circuit. They're all consistent, all connected correctly, because it will find loose connections because the readings will vary. So if we had a loose connection in here, then you might get R1, you might get 1.05, and then R2, if you had a loose connection, this might go to 1.5 ohms, which would suggest somewhere on there that you have a loose connection on the neutral or the earth or whatever it happens to be. So you can go around and find it. So that then gives you your reading. Point to note though, you may well have a spur off of this circuit. And when you have a spur off the circuit, because it's still part of the circuit and still needs testing. Now when we test with this circuit here, so you're going to test on your socket at this point here, so it's going to be the resistance of all of this plus the resistance of these cables. So although we got 0.51 as you go round, if you've got a complete ring, it'll be 0.51 plus whatever the length of these cables happen to be. So if they're another half a ohm or quarter of an ohm or whatever, it will be added on to this value here. So that still would be your R1, R2. So if this is the highest value and you get 0.6, then that is your R1, R2. Despite it not being part of the ring, it's still spurred off of it because the spur is this connection here. So that is still your ohmic value and would be your highest value and still needs checking. So it must make sure that all spurs are done as well. That's good in theory, but if these cables were literally this long, so you literally put a spur next to another socket, you will never find it. Not resistance readings. You need something a reasonable length to denote whether you've got a spur on the ring. And this was your R1, R2, so R.51 of an ohm. What we don't need to do is R2 only because it's one or the other, so that then is your R1, R2. What I would tend to do, certainly for an exam, is put R1 plus Rn and put it down here as 0.51 ohms. But also, in addition, what you might normally do if you was doing an exam, do this check of the little r1 and little r2 and little r1 and little rn to make sure that these values tally for what you've actually got. But if you, as it says on there, on a separate sheet as necessary, and then I'll give you a lot of room on the test sheet.